A YouTuber, John, was wondering about the internal workings of meters. He was wondering about current and voltmeters. And here's 3 multimeters, and each one will measure at least volts, current, and ohms. And when you're measuring voltage or current and you're not sure of how much is there, well, it's always a good practice to start at the highest part of the scale that you're going to measure and then work down. Before I get into the internal workings of the meter, it's a good idea to have an idea of what the meter is measuring, or what we're trying to measure. And a good analogy, and one that's been used for years, is using water. And here I have a water tank that's pretty much full, and a pipeline out of it that goes to somewhere. And right now we can't tell if there's any flow in that pipeline. But if we put in a water flow meter, and here we have just opened up the valve and the water's flowing pretty good, we can see that the water is flowing through the pipe. But as time goes by and the tank gets lower, we can see that the water is still flowing, but the flow rate is much less. Here we're back at the beginning again, and if we were to add some resistance in that pipe like this, in other words, the water's going to take longer to get through it, plus the diameter of that part of the jagged pipe is less. And now when we take a look at it with the flow meter, it's already flowing at a slower rate. And what it's measuring is the water current through that part of the pipe. But if we put that anywhere along that pipe, we will see the same current. Now, as the tank becomes less, we can see that the flow also becomes less. But it also, because it's a slower flow, it does take longer to empty the water tank. So adding a resistance in the line impedes the flow. And if we take a look at the tank, what that equates to when we get into an electrical circuit is the potential. And here I've drawn an electronic simple diagram of a current meter, which measures in amps, and it measures the flow of electrons. You can see the symbol for the resistor, and the voltmeter is across the capacitor that I'm going to be using. And when I charge that capacitor, we have potential, and that is what the voltmeter is measuring. Here is a demonstration of the potential across a capacitor. I have charged that large black capacitor, and now I'm connecting the circuit so that the capacitor will discharge, and all that's in there is now a capacitor and a resistor across it. I'm using the 12 volt DC supply terminal strictly as a terminal. The only voltage that we're measuring is across that large capacitor. And as you watch this, you can see that it started to move fairly fast, but as it gets lower in voltage, it also takes longer to discharge. And if we watch this long enough, it will eventually get down to 0. Here is a block diagram of that voltmeter. Actually, it's a multimeter, but right now it's set up to read volts. And you can see that on the positive side we've got a scale of resistors depending on how much volts we're going to read. On the negative side we've got it switched over to DC. That's what we're measuring. And then both end up at the meter movement to drive that meter. Now if you had a digital meter, it's that signal that's going into the meter movement that would be sampled to drive the digital display. So in other words, if you got a digital meter, you've got this part of the meter also. And if we were measuring AC, we'd have the meter switched to the AC mode. Okay, now let's take a look at the current meter, or the amp meter. Here I have hooked up a digital ammeter to actually the last circuit that I built on my trainer, and you can see that I've taken the positive 12 volt lead and hooked it up to the red lead of the meter, and then the black lead is connected to where the original 12 volt used to be, putting it in series with the entire circuit. And you can see that there's a little bit of difference in the current draw between red and green. Red draws a little bit more current than does the green. Here's a block diagram of an amp meter or current meter. And what we have switched in here is a shunt across the two leads. Now that shunt is very, very low resistance, and of course when you're measuring current, it's in series with whatever it is you want to measure. And because that shunt is very, very low resistance, that's why when I put it in series with my last project, the project worked just fine. It saw it as a wire. Well, there's a very, very small amount of voltage that is developed across that shunt, and it's this that is sent up to the meter movement. And in that digital meter, what goes into that meter movement is sampled by the digital meter to drive the display. And if we were measuring AC current, of course we would switch over to the AC mode. Now let's take a look at that resistor. And it's best to measure resistance when the circuit is off, and best of all, if it's out of the circuit, because there might be something in parallel with what you're measuring and you might get a false reading. Here I have 3 resistors, and this backside here is the same connection. They all read 0, so they're all connected at one point on one side. And to measure the resistance, of course, you just hook it up to the other side, and this one reads, let's see, about 326.7 or so. Then the next one is 22K.49. And the top one reads 100.4.5. Here's a block diagram of an ohm meter, and now you can see why it's important that there's no current going through the resistor. It's because the ohm meter supplies its own power with that battery. And we still have our scaling resistors, and on the other side it goes directly up to the meter movement, and at the meter movement this is where my digital ohm meter was sampling to drive the display. I hope this video helped you understand the voltmeter, the current or ammeter, and the ohm meter a little bit better. Thanks for watching.